Okay, yesterday, we talked about adding, subtracting, multiplying, and dividing functions, right?
Yep.
So given two functions, we can add them, we can subtract them, we can multiply them, and we can divide them. Let's just review really quick. If you see something like this, what does that mean?
You add them,
You add them. What are you adding?
the F and then you G, so 2x squared plus 8.
Yep, 2x squared plus 8
Plus
plus
x minus 3.
x minus 3. Now, that's the new part. The old part is you should have, when you walk in the door here, you should know how to combine like terms. Do you remember that?
Yeah.
What do you do?
You add the 3 and then 8.
And what do you get?
5.
5. Now, for subtraction, what's different about these two?
You're going to distribute the negative.
Yes, you have to distribute the negative. So for this one, it says f minus g. You're going to take this f function, which is 2x squared plus 8, and if you subtract the g function, that means you're going to do what with this negative? Distribute it.
Plus 3.
Okay? Whereas this one, you're going to start off with the, which function?
G.
The g.
So would you use the plus 8 and the plus 3, do you combine them?
Yeah,
Okay.
yes, yes, so you'd write 2x squared minus x plus 11 for that one, yep. But this one, why is this one different? This one starts off with g, and then does what?
Subtract that.
Subtracts f. So this would be x minus 3 minus 2x squared plus 8. So we have to distribute the negative here. Now how come over here, when we had f plus g of x, they didn't do one that said g plus f of x? What if I would have had
It would just equal the same thing.
y? Do you know why?
I mean, if you flip it around, regardless, it's going to equal the same thing.
You know why?
No.
It's a property. Just thought I'd mention it. The commutative property for addition says that f plus g is the same as g plus f. But we don't have a commutative property for subtraction. So these will be different, but f plus g is the same as g plus f. You'll get the same answer. Because we can add, if I asked you to add 5 plus 3, it's the same as 3 plus 5. But 5 minus 3 is not the same as 3 minus 5, right?
Yeah.
Okay, so I want you to understand that. Sometimes I wonder, we teach those properties in middle school, but do you really understand what you're doing? That's a good example of the commutative property for addition. All right, now, what's the difference between these problems and the ones we just did? These are adding and subtracting, these are multiplying and dividing. When you're multiplying, you're going to at times distribute and at other times FOIL. So we did these yesterday. Does everyone understand how to FOIL? Now the one that's going to cause you some grief is this B. Because you had to, when you divide, you always want to simplify, and unfortunately, simplification on these involves factoring. So this one, it's 3x squared minus 11x minus 4 over 3x plus 1. Now, this is again something you should have already learned, how to factor this numerator. This numerator factors to be 3x plus 1 times x minus 4. Now, why do we need to do that? So we can cancel any products. These two are the same, so we can cross these out. Now, we do want to state, because we have a fraction, you never want your denominator to be equal to 0. So if you set this 3x plus 1 equal to 0, x cannot be, does anyone know? You have 3x plus 1. I just want to mention this. You never want 0 in the denominator of a fraction. So they do talk about the domain of this. You guys are off the hook with that part. But I just want to mention, if you see something that x cannot be, anyone know what x cannot be? What did I just do? Brought this one over and then divide by 3. So x cannot be negative 1/3. Why can x not be negative 1/3? Because 3 times negative 1/3 is negative 1, and negative 1 plus 1 is going to give us a 0 in the denominator. So this is like a danger. A danger zone would be, don't have x ever equaling negative 1/3. So once you cross these out, you won't see that, and you won't know what your domain is. So before you do any crossing out, if you have a fraction, you always set the denominator equal to 0 and say, hey, stay away. You're just saying, stay away from negative 1/3. X cannot ever be negative 1/3 because you would get a 0 in the denominator. Just wanted to mention that. Okay, did anyone have trouble with this? 2, what does this say to do? It says take 2, multiply it by the f function, then subtract the g function, and then subtract 3. So 2 times the f function, so 3x squared minus 11x minus 4, minus the g function, and then minus 3. Okay, so what will I do with this 2? 2 what?
Distribute all of them.
So 6x squared minus 22x minus 8. What do I do with this minus sign?
Distribute it to all those. Negative 3x minus 1 minus 3.
And then minus 3. So what items go together? Well, that's the biggest, that's the boss.
And minus 25x.
These two are like terms, minus 25x
Minus 12.
minus 12. And that was your best answer for that one. And the last thing we did these yesterday, how do you evaluate a function? We're gonna be doing a lot more of this stuff. What do you do with this? F of x is equal to x squared minus 3x plus 5. If I say, what's f of negative 6? What do they want you to do with this negative 6? Plug it in. So what is negative 6 squared minus 3 times negative 6 plus 5? What's this?
36.
What's this?
Plus 18. Plus 5.
And what do you
Plus
get?
59.
59. Good job. Okay, so this back page, you're gonna do for homework. You should have started it. You didn't, that's fine. But I want you to go to this page right here. These are called composition of functions. What you're gonna do is plug one function, you're gonna plug a number into one function, and the result is plugged into another function. These are called composition. So now, I wanna tell you this. When you see something like this, F with a circle, and then G. This is read F of G, of X. Now, this does not mean multiply. If you see F dot G, that means multiply F and G. This is not the same thing. And now I want to also bring to your attention, there's another way, this is called a composition. There's another way to write this. F with a parenthesis, then G with a parenthesis, X parenthesis parenthesis. These mean the same thing. And it is read F of G of X. F of G of X. This is how you do these problems. The number closest, you go in the middle, in the inside. You plug this number into this function. So take this number, and what's closest is the G function. You're gonna evaluate whatever number or letter, sometimes they'll give you a letter, you're gonna plug that into the G function. Then what comes out, you plug that result into the F function. Does that make sense?
Yeah.
Okay, so I wanna start off with, we're gonna skip A, because I think A is the hardest problem. So I wanna build up to that. We're gonna do B. Travis, is the camera okay?
Yeah.
Okay. So, everybody see this F of G of X, of -3. This can be written, I want you to be aware that some books will write it like this. It means the same thing. It means the same thing. So what you're gonna do, you're gonna plug -3 into which function? The G. If you were to plug -3 into this function right here, tell me what you get. What's -3 squared?
9.
9. Now you're gonna take 9 and plug it into the
F.
F function. So what's F of 9?
9 minus 5.
What's 9 minus 5? 4. Everyone got that? So what is F of G of -3? It's 4. 4 is your answer.
Can you do another one?
We're gonna do like 20 of them, how's that? You will get this. Okay, this one reads G of F of -3. Or it could be G of F of, whoops, I'm gonna put a -3 here. Okay, what is this telling you to do? It's saying, hey, plug -3 into what function first now? What's closest?
X minus 5.
The F function. So if you were to plug in -3, and where is the F function? Right here. So what's F of -3? If you plug -3 here, what do you get?
-3 minus 5.
Which is what?
Negative 8.
-8. Now we're gonna plug -8 into the,
G function.
so let's plug -8 into the G function, which is right there. What's -8 squared?
64.
64. Easy?
Yeah.
Okay, they're gonna get easier and easier and easier. We're gonna keep doing them. Let's keep going. Everybody with, and I didn't forget A. We're gonna get to A in a minute. Read this. Now this one defines, we have two new functions. G of X is 2X and H of X is X squared plus 4. So what are you gonna do with H of G of 1? Where do you plug 1 in?
To the 2x.
Into the G function,
Yeah.
into the 2X, she's right. 1 goes in to the G function, so what's G of 1? What are you gonna write? 2. Now you're gonna plug 2 into the
H function.
H function. So what's H of 2?
2 squared plus 4.
Which is what?
8.
8.
8. Excellent. So this is your final answer. You get it?
Yeah.
Let's keep going. Tell me what to do here, because these can be confusing.
H parentheses, G parentheses, 5 parentheses.
H parenthesis, G parenthesis, negative. You don't have to do that. I just, some people like it, okay? So what do you do first?
You plug -5 in for G,
Yep,
so it would be 2 times -5.
Yep.
-10.
yep. Then what do you do?
Then you plug it in for the H.
Mm-hmm. What do you get?
Just add 4 squared. 100 plus 4, 104.
Good job, 104. Okay, how would you do 29? H of G of -2. We're gonna plug -2 where? What do you get? And then what?
and you plug it in for h.
What do you get?
Negative 4 squared is 16 plus 4, so that's 20.
Good. Now, I see that you're getting faster at these. First started writing it all out. Do you have to do that? Not necessarily. If you can do this in your head, plug -2 in where?
To the h.
Okay, what do you get?
2 squared plus 4.
4 plus 4 is 8. Put 8 into that. 8 times 2 is 16.
And then 8 into the g function. What's your answer? 16. Next one. 0 in the what function?
H.
What do you get?
4.
0 squared plus 4 is 4, and then 4 into the,
G.
and what do you get?
8.
Yep. Okay, now instead of a number, what do we have?
11.
A letter. Let's see if you can do this one. You're gonna plug the letter A into the H function. Well, where's the H function? We're gonna plug an A in here.
A squared
A squared,
plus 4.
good. Now we're gonna plug this into the G function. So it'd be 2 times A squared plus 4. Now, if it's not too much to ask, can you do something to this problem?
Wait, why'd you plus
2.
4?
2a squared.
Because
plus
we
b.
plugged A into the H function. We plugged, where you see X, you're gonna plug in an A. So you
Okay.
get A squared plus 4.
Okay, but the second one for G, wouldn't it just be 2a, 2 times a, not 2 times a squared plus 4?
No, because this is now,
You can't
This-
add those, there's not like
you have to
terms.
plug this all into the G function. This all goes into here. So it's 2 times what the result.
I'm confused.
You're confused? Okay.
Are we solving for A now?
No,
No,
X is A. Let me start over.
that number is.
So, you're gonna plug A into the H function. Wherever you see an X, you put an A in H. So what is H? H is X squared plus 4. I'm gonna write it out for you. If you were to plug an A in here, what do you get?
A squared.
A squared plus.
A squared plus 4.
I'm not sure.
If you put an A into this function, you get A squared plus 4. So this all goes into the G function where you see X. So what is 2
Why
times?
is, I just don't get why it goes into the G function.
Because that's what this says to do. It says first put A into H, and then what the result goes into the G function.
If she-
Before we had numbers as an answer, but now because we can't combine like terms, our answer for h of a is a squared plus 4. So we're plugging that answer into the problem. That makes more sense.
Yes or no?
Yeah, I think so.
2a squared plus 8.
Okay, we're gonna keep going with these letters now.
Wait, what was the final answer?
2A squared plus 8. Let's try another one. What does this say? G of A. So what do they want you to do?
Plug it into
Plug it
G
into-
plus.
They want you to plug A into the G function. So you're gonna plug A into the G function. If you plug A here, what do you get?
2a.
2A. And then you gotta take this and plug it back into the G function again.
2 times 2.
So 2 times 2A,
4A.
4A. Does that make sense? This one's hard, a little harder. H of A. you're gonna plug A into the H function. Plug A into the H function. If you plug A in here, what do you get?
A squared plus 4.
You get A squared plus 4.
Square plus 4.
Now you gotta plug that back in to the H function. The result of this goes into the H function.
What is
So
squared?
now you're gonna plug this in for X. So you get A squared plus 4 squared
Plus 4.
plus 4. Mr. Duke, help me.
Okay,
You
so
square A
the
squared.
first composition, we plugging A into the A squared plus 4, and that's what we get. We can't combine those like terms. So now we have to compose our new answer into the function. We have to we have to substitute what we got for our answer into the next function. So because we can't combine like terms, you're taking that and you're putting it back in for wherever you see an X.
I thought you would just be boiling it.
You can, we didn't get to that part yet. I'm gonna do this, see if this makes sense. Okay, what did I just do? I wrote them out separately. This is the H function and this is the H function. So watch, this says H of A. See if this makes sense. If I plug A into the H function, so in other words, A goes in here, what do you get?
A squared plus 4.
You get A squared plus 4.
I get the first part. It's the
Now
second
you're gonna
part that
plug
confuses
this into this function
A
here.
squared, squared.
You get A squared plus 4 squared, so in other words, wherever you see